In this presentation, I'm going to cover these points. We have a population of 1 million persons, and we collect data from a sample of 1,000 persons. We want to know the height of this sample, so on the x-axis, we arrange the values from the shortest to the longest person, and on the y-axis, we record the frequency of each value. So we have this frequency distribution curve. The mean is one value to represent the group. In this example, we have an average group with average height. Their mean is 160. We may have another sample of short people, and the mean for this new group is 130. Or we may have a sample of longer people, and the mean is 190. So the mean is one value to represent the group. What about the rest of the group? Are they close to the mean or away from the mean? This is achieved by knowing the variance or the standard deviation. So in this example, the group is averagely spread around the mean. In this new example, the group is close to the mean, and in this example the values of the group is away from the mean. So the variance or the standard deviation give us information about how much the group is close or away from the mean, how much the group varies around the mean. Let us simplify things. Suppose we have a sample of 5 persons. Written down here is the height of each one. And if you want to calculate the mean of this group, so we are going to add the height of each person and divide them by the total number of the group. So x bar, this is the mean, equals the summation here, this is a large or capital sigma, the summation of x divided by n. Is it average group? Is it short group? Is it long group? How much the rest of the group varies or spread around the mean? Again, let's see this example. In the upper row, this is the first 5 persons. The difference between one and next is only 5 centimeters. In the middle group, I change the value of the first one and the last one, make them shorter or longer. And in the bottom, I change the values more to have a shorter or a longer than the rest. I calculated the mean for each group. As you can see, almost the same. In the upper group, the mean is 165. In the second group, 164. In the last group, 166.8. Now, what about the spread? To know that, let's see how it is calculated. Now, let's have the first row. The mean is 165. So the first person is shorter than the mean by 10 centimeters. The second one is shorter by 5 centimeters. Third one, no difference. Fourth one is longer by 5 centimeters. Last one is longer by 10 centimeters. So that's it. The difference of each of the values from the mean. So if you want to know what is the difference of the whole of the group, then I'm going to add all these. If you add all these, you will find that the result is 0. Why is that? Because some of the values are with the minus and some of the values are with the plus. And this will be always the case. The mean is in the middle. Some of the values below it, some of the values above it, and they will cancel each other. So to get rid of this problem, we thought of squaring numbers to get rid of the minus sign. So in this column now you can see all the values are squared and then they were added. That's why they could get rid of the minus sign. This value in this table is 250. If we divide them by the total number, in this case it's 5, then this is known as the variance. So the variance is just the squared differences divided by the total number of the sample. Now, as we square things, if we have the square root of this value, this is the standard deviation. So let's repeat the calculation. We calculate the difference of each value from the mean. If we add them like this, the net result will be 0. So to get rid of the 0, the differences were squared. The squared values were added together, divided by the number of the sample, that is the variance. If we take the square root, then we get the standard deviation. So the variance, or S square, equals 250 over 5, while the standard deviation, S, is the square root of 250 divided by 5. So let's see, I calculated the three groups. In the upper group, the standard deviation is 7. In the middle group, the standard deviation is 11.5. The last group, the standard deviation is 25. So as you can see, when some of the values are away from the rest, the standard deviation increases. So the variation we can know by the variance or the standard deviation. If the values are high, then the variation is high. If the values are small, then the group is surrounding the mean. These two groups have the same mean, 100. But the group in red, close around the mean, as you can see, the standard deviation is 10, while the group in blue varies around the mean, it extends to the periphery, so the standard deviation is high, it's 50. What about ophthalmology? Here in the field of vision, the sensitivity of each point is compared with the normal values, and we have this table of total deviation in case of Humphrey or comparison in case of octopus. If this is the normal hale of the vision, and these are the values of the patient, and we want to know deviation of the patient from the normal, so the difference between each test location and the normal is recorded. Then we want to have one value to represent all these differences. So we add these differences, divide them by the number, then we get the mean. So this is the mean deviation of the patient from the normal. One value to represent the whole group. This is the case here. Total deviation, each point below the normal with so and so, All these differences were added, divided by the total number of points tested, and we have this value, mean deviation. It is minus 6.73. In this example, the patient's halo vision is depressed in some locations more than others. And this is the differences. As you can see from the left side, the second point is minus 18, while the first one is only minus 5. So there is ununiversal depression of the field. We can calculate the mean as we did before, but we want to calculate the variation. This can be achieved by calculating the variance or the standard deviation, the same way I've just explained before. In the field, we have different names. In case of octopus, we have loss variance, so this is the variance, or in the new software, they print the square root loss variance. Square root of the loss variance is nothing but the standard deviation. In the Humphrey, the term is pattern standard deviation. It's a standard deviation, but the Humphrey machine give it the name pattern. So, 3 examples. The mean will give us impression about the height of the field as a whole. If it's below 6, we say there is mild depression. Between 6 and 12, we say there is moderate depression of the field. Above 12, it's a high depression of the field. While the shape of the field, we know it from the pattern standard deviation or loss variance or square root loss variance. As we have some points away from the rest, the variation will be high. So in this example, this is the mean. This is severe depression. This is severe depression. This is standard deviation, pattern standard deviation. This is loss variance. So if you want to change this into standard deviation, we need to use a calculator and to have the square root. Here is the value, and we ask for square root, so it is 8. In this last example, it is already written in the form of square root of the loss variance. Keep in mind the square root of the variance equals the standard deviation. If the value is small or if the value is large, then we know how far data varies around the mean. Now this is the last point, the coefficient of variation. It is the ratio of the standard deviation to the mean. In this example, the standard deviation is 15, the mean is 100. So we say that the coefficient of variation is 15%. In this example, it is 5 to 100, so the variation is 5%. The higher the percentage of or the value of the coefficient of variation, this means that the variation is more and the data are away from the mean. So the coefficient of variation, it's a scale that tells us how much the data varies around the mean. We can see this when we see the printout of the specular microscopy. Here you have these values. Average, this is the mean. SD, this is the standard deviation. CV, this is the coefficient of variation. So here the standard deviation 170 to the ratio 461 and percentage. So if we solve this, we multiply this and multiply this, divide, this is the first, this is the bottom, divide them, then we get this percentage, which is 37%. In this example, the number of the cells are the same, 2,476, all examples the same. But here the coefficient of variation is 4%, here it is 25%, here it is 50%. So simply, looking at this number, you can figure out if there is much variation between the size of the cells or they are very close to one another. The central cornea normally loses 100 to 500 endothelial cells per year. When these cells die, they slough off to the posterior, from the posterior surface of the cornea into the anterior chamber, creating gaps. Endothelial cells adjacent to the defect move to fill the gap. Cells either stretch or slide into different positions, or they fuse together. This movement creates variation in the size of the cells, known as polymegathism. There is always some degree of polymegathism in the corneal endothelium. Coefficient of variation normally, when it is measured, between 22 to 31%. But values higher than 40%, the patient is at risk of developing corneal edema. To sum up this talk, the mean is one value to represent the group. The variation around the mean, we know it by the variance or the standard deviation. Standard deviation is the square root of the variance. How much spread? We have it in a form of percentage. This is the coefficient of variation. Small coefficient of variation, data are around the mean. Large coefficient of variation, data are spread away from the mean. Thank you for your attention.